three different types. And these types are going to be important to understand from a design perspective. Because just like one of these is going to overlap with the Z, and that is the one sample version. So there is a one sample T test, and there is a one sample Z test. And we already talked about mathematically, they look really similar, right? The math of a one sample Z test, right? A sample mean around an expected value, population mean, over a standard error where the population variance is known. Also then, right, if I say population variance, it's the same as saying you know population SD, one's just the square root. Okay. We normally talk about it in terms of knowing the population variance. Okay, so this is the equation. We're dealing with the same kind of idea here. A sample mean against an expected value, but now we don't know sigma. That's the only thing. So we estimate it from our samples data, right? We don't have a value that's given to us where they say sigma equals 20. They're not going to tell you that anymore. You have to calculate it from your data, right? That's the only real change mathematically. And this changes our distribution a little bit, because if you remember what I told you, when we talk about a type of test, it indicates the type of distribution we are using to compare that value to determine whether or not it's big enough to be significant, right? So when you learn those critical values for a Z-score, that's not the same as for T. Okay? It's a different distribution. It's going to look very similar. We're going to talk about it, but it's different, just slightly. Okay? So the math looks the same with this itty-bitty change. The distribution looks the same, but there's an itty-bitty change. Okay? So it's really the same logic with very small alterations. So it shouldn't be that much of a conceptual leap. Okay? So we're going to talk about all those pieces. As we move forward, we're going to talk about in the coming weeks additional types. We're going to talk about an independent two-sample test. And we're going to talk about what's called related sample tests. And it's going to be important to be able to understand these, because after that we go into the F tests, and there's an F test for both of these types of things as well. So everything kind of connects. Okay? So don't think that like, oh, we're past that, I don't have to worry about it. If you understand each level, the next level is just always easier. So really make sure you're paying attention to the ideas. So right now, what we're talking about tonight, design-wise, is getting one group of people, right? It's a group, it's a sample. One group of people, calculating an average for that group, right? And testing it against an expected value. Does that make sense? And to do that, now to measure our standard error, we just have to estimate sigma using standard deviation from our sample. Okay, so not an enormous change. A couple things will change just a little bit, and we'll try to highlight and emphasize all of those things. But first, I want to tell you the story. And like every single good story probably ever in all of humanity, it starts with alcohol. So here's, yeah, really it does. Actually, a lot of statistics started with something to do with agriculture. And in the early 1900s, a lot of agricultural revolution occurred because of statistics. So the reason we have more food per capita now than we did 30 years ago is greatly due to statistics identifying the best ways to grow food. So like, if you guys don't know, we have more than halved poverty the world over in the last like 10 years. People don't seem to realize that. Everyone thinks poverty is horrible, and it's because people who learned about poverty 50 years ago still teach about it, and they don't look at the new data. Poverty, in 1990, worldwide, there was 1.8 billion people starving, even though there was only about just shy of 6 billion people on the planet. Now, it's 767 million. It's like 1/3, even though we actually have more people on the planet. So, like, we do a lot better at growing food, and a lot of that's because of statistics. Well, in this case, they were growing food to make beer because, you know, you've got to get wheat and barley and all that stuff to make beer. And the guy who invented the t-test worked for Guinness Breweries. And Guinness wanted to figure out how they could grow more wheat more quickly and figure out which methods were superior for all kinds of things. They were trying to test pesticides and turnover crop rates and all this kind of stuff to figure out how do we do this best, okay? And they had to deal with the fact that the tests they had weren't really good enough,